This looks elaborate, but it's basic plug points into equations, right? We have the equation, and we were given 4 sets of points that could go with it, right? So just pick one and plug it in and see what happens. So for me, I would scan all these at first and be like, okay, at least the x points are consistent, right? -1, 0, and 1. But I'm not gonna start with -1, I'm gonna start with 0, right? Because 0 is a very easy number to think about. So I would just plug in 0 and see what I get. And you have to remember what 0 does with exponents. That's a very key rule. So if we had q of 0, we would have 32 times 2 to the 0. Well, 2 to the 0 is 1. Anything to the 0 is 1. So this is just 32 times 1, which is 32. So q to the 0 is 32. So anything that doesn't have a 32 there is gone, right? So that gets rid of choice A, gets rid of choice B. We are okay in C and D, so now we got to test something out. But test something else out. And make sure you're smart about what you are testing, right? I look at the 1 and I see, okay, well, that's not different, right? That's 64 in both cases. So I'm not going to bother with that. I'm going to try the -1. So let's do that. Q of -1 is 32 times 2 to the -1. So the problem with this is most people forget what 2 to the -1 is. You can put it in your calculator. You can put it in a regular handheld calculator. You can put it in Desmos. I'll show you another way to do it in Desmos in a second. But 2 to the -1, you probably want to remember this. Basically, what a negative exponent does is we can get rid of it by moving the thing that it's attached to. So 2 to the -1 is the same as 1 over 2 to the first, right? So we drop the negative from the exponent, but it's still an exponent. But we move the term, the base, within a fraction, right? So we are just moving it down. If it's on the bottom, it goes to the top. If it's on the top, it goes to the bottom. And then that gets rid of the negative. So now it's, 2 to the first is really easy. That's just 1 over 2 in this case. So 32 times a half is 16. So choice D is the answer. But, I get why that's a little hard. Some people don't have that ready knowledge of how negative exponents work, and it might make you panic or make you do something weird. Maybe you do know that it involves fractions in some way, but that's why you pick C, because it looks like it's got that fraction. But we can do this with Desmos if we really wanted to, using a table. I don't think this is very efficient here, but I'm showing you because there might be other questions at some point where knowing how to kind of create a table is really simple, is really useful. So the first thing I would do is create the function. So let's just go, we can stick with Q, it doesn't really matter. Q of X is equal to, what did they say, 32 times 2 to the X. So there you go, to the X. So we get a nice graph, and we could, if we wanted to, just kind of like look along the graph, look for the -1, look for the 0, look for the 1. So we have all sorts of options, but I'm not going to do that. I'm going to hit this plus in the middle here, and that's going to give me a table. And I'm going to just type -1, 0, and 1 for my x's, because that's what I've got. So I know the table now is oriented the other way, but it doesn't really bother me. And then instead of y1 here, let's change that, right? Because I don't want, I'm not creating random points. I want this to reflect the equation that I've got. So I'm going to go back, I'm going to go to Q, and I'm going to, again, do my little x here, but instead I need to put x1 so I can tell it to take all the values of x that I put in the left column, plug them into the Q of x equation at the top, and then spit out the y value that goes with it. And then there you go. We've got 16, 32, 64. That's exactly what we had in choice D. So that is a way to do these. Again, I don't think that that's more efficient than just doing it by hand, because the numbers that they gave us were so simple. The equation was relatively straightforward. Plugging in 0, plugging in even -1 isn't that big of a deal. But it's a great opportunity to show off that Desmos has a lot of capabilities. Maybe there's a question where knowing that this table feature exists can kind of save you some time. So there you go. Hopefully it helps.